Okay, let's walk through homework problem 6.3.23T. So obviously the numbers I'm going to have here are going to be slightly different than what you get when you will have the homework problem. However, you should be able to follow the steps I have in solving this one for corresponding with solving your problem. So here we're looking at height of live characters at amusement parks and their height requirement. So we are given the mean and the standard deviation for both of these populations. And we have two problems here that we're going to solve. First is finding the percentage of women meeting the height requirement, and the second one is solving the percentage of men meeting the height requirement. So let's start looking at the percentage of women meeting the height requirement. This corresponds to the material in your text in section 6.3 that talks about finding an area probability for a corresponding value of x. So if you're looking in your book, that's what we're matching this up with. So we have our mean and we have our standard deviation here for our population of women. We're told to assume it's a normal distribution. Now the figure I have drawn up here for you has both the height distribution for the women, as you can see, which has the mean of 62.3, right? And I've also drawn below it the corresponding z-scale that's going to relate to it. So you can see there on the z-scale, we have the mean is equal to 0. So we have our minimum and our maximum requirements. So I've drawn these in on the figure. So we have our minimum requirement of 57 inches, and we have our maximum requirement of 74 inches. And notice I've drawn those lines all the way down through the z-scale because what we're going to do is find our corresponding z1 and z2. Now, the area that we want to be able to find the percentage for is the area that's in between the two. So we're not solving just to the left or just to the right. We're not asked for less than or greater than. We're being asked to give the percentage of individuals that meet the height requirements. And so we've got two corresponding z's that we need to look at. All right, so remember, if you're trying to solve a space in between, you're going to be taking the area for Z2 and subtracting out from it the corresponding area for Z1. Because remember, everything sums from the left. Okay, so solving for Z2 using our formula, we have x minus mu divided by the standard deviation. So that's going to be our maximum, so that's going to be 74 minus 62.3 divided by 2.3. And then our z1 is using the same formula, but now our x that we're interested in is the minimum. And when you solve through, you should be getting your z-score for z2 would be 5.09, and your z1 should be negative 2.30. Now you're going to look up the corresponding probability area in the z-distribution table. So remember, using your z-score of 5.09, you go locate that in the margins of your z-table and bring that in to find the corresponding probability and area in the body of the table. And you can see there that it's 0.99999. Okay? And then we're going to subtract from that the corresponding probability area for the z1. So again, you're going to look for negative 2.30 on the outside margins of your z-distribution table coming in to find the corresponding probability area for that, and that's going to be 0.0107. You subtract the probability for your z1 from your probability of z2. That should give you 0.9892, which corresponds to 98.92 percentage. Okay, so that's the percentage of women that meet the height requirement for one of these live action figures at an amusement park. Okay, you should be able to go through and now repeat that process for solving the same problem for men. And we're going to finish up here looking at solving for part C, which is where they're asking if the height requirements are changed to exclude only the tallest 5% of men and the shortest 5% of women, what are the new height requirements? Here we're using the second part of section 6.3 where we're finding the value of x for a corresponding probability area. You've been given the corresponding probability area of 5%. Okay, so you can see your figure over here on the right where I've drawn this out again. We've got our height distribution of men, and below it we've got our corresponding z-scale. Okay, we've got our z-scale mean of equal to 0. We've got our mean for the height distribution of men at 68.4. We know the probability area is 0.05. So what we want to know is what is the corresponding x value for that. So to do that, we're going to find the corresponding z value first. So we've got our formula here of x equals the mean of the distribution plus the z-score times the standard deviation for that distribution. So we're going to locate the probability area of interest in the body of our z distribution table, but remember our z probability distribution table sums from the left. So for the men, we're going to be looking at here is going to be taking 1 minus 0.05, okay? So that's going to give us the probability area all to the left up to that 0.05 value, and that gives us 0.95. So if you locate 0.95 in the body of your z distribution table, so that's the probability area that we're interested in, you're going to find it has a corresponding z-score of 1.645. Now we're going to take that 1.645, we move that back up and plug that into our table, into our formula to solve for the x. So we're going to get 68.4 plus 1.645 times 2.9, which gives us the value of 73.17. All right, and again, you should be able to then repeat this for the what would be the height requirement for excluding 5% of the shortest women.